So in this example, we have substantial evidence of heterogeneity. That means that we probably can't combine all of the studies to create one large, weighted summary effect measure, because we have evidence that they're not all estimating the same thing. So this is one of the most critical aspects of meta-analyses. We have a variety of studies, and what we'd like to do is combine them using an appropriate statistical approach to obtain a more precise estimate of the comparison we're interested in. So for example, here we've got 17 different estimates of the comparison between seroprevalence of cattle and buffalo. And we'd probably like to combine them, if it's legitimate to do so, so that we got a very precise estimate of the difference between cattle and buffalo. However, to get that combined estimate, which is called the summary effect measure, so each study has its own effect measure, and if we combine them, we get a summary effect measure. To get that, we must first assess whether it is valid. And the way we do that is by assessing heterogeneity. This is very analogous to the idea when we assess effect modification. We have strata, and we must ask the question, are the strata estimating the same thing? And if we have no evidence to reject the null hypothesis, recalling the work you did on the Breslow and Day chi-squared test for interaction, if you don't reject that, then you can combine the strata and obtain one adjusted estimate. This is a very similar concept. So in this example, it would seem invalid to combine the estimates. The next step then is to explore what is the source of heterogeneity. And we can do that in this software, and that's called Exploring Heterogeneity. We've already discussed that there are two sources of heterogeneity. There might be clinical or contextual heterogeneity. They're characteristics of the population that may affect the effect size. This is exactly the same concept as effect modification at the individual animal level. So there's a third variable, a characteristic that causes effect modification. Well, this is the same idea. Those clinical or contextual characteristics are some of the information that you tried to extract. Region, production system, sex, they may all be contextual or clinical sources of heterogeneity. And if we're able to identify them, they help us to explain why are we getting different estimates. The other source of heterogeneity is methodological. It may have something to do with the study design. Now, the most important factor in the study design in this example that we're looking at is probably the assay that was used. So if an assay has very low sensitivity and specificity, it might not be able to detect the difference between cattle and buffalo compared to another highly accurate assay. So that might be one source of methodological heterogeneity in this example of seroprevalence. However, if we were looking at an intervention question, for example, a question about vaccination, then a methodological source of heterogeneity might be whether the authors failed to randomize or not. Because we know that randomization is a potential source of failure to randomize is a source of selection bias, which will manifest itself as confounding bias in the study. So studies that fail to randomize might have a different effect observed than studies that do randomize. In fact, there's very good data that that actually happens. Finally, another really common source of methodological heterogeneity is failure to blind in intervention studies. If we don't blind and we have a very subjective outcome, then it's possible that we will have differential misclassification of the groups depending upon whether they were allocated to the vaccine or not. So you can see that your basic epidemiological concepts are really, really important in meta-analyses and systematic reviews, because many of the things that we're going over here are the basic concepts. We've talked about effect modification, and we're now relating that to the effect on the study effect. We've talked about sources of bias, selection bias, and confounding bias, and information bias. So all these concepts that you've done in your basic course are very similar and fit exactly into meta-analyses. Now, in this example, we're not able to calculate a summary effect measure because it would not be valid. We have evidence of heterogeneity. But that's only for when we have the odds ratio as the measure of effect. What happens if we change it to the risk ratio? So I'm using this second button on the left and I'm going to change it to the risk ratio, because as you will be aware, the assessment of interaction is only valid for the effect measure. So if you say something has interaction on the odds ratio scale, that does not mean it has interaction on the risk ratio scale. And the same applies in meta-analysis. So what I'm going to do is I'm going to click on the risk ratio, and you'll see, yes, there is changes, but we still have interaction on the risk ratio scale. What about if we look at risk difference? And yes, we're still seeing interaction or evidence of heterogeneity on the risk difference scale. So that means that we're not going to calculate a summary effect measure in this example. Instead, we are going to explore heterogeneity by doing a subgroup analysis. So how do we do a subgroup analysis? That is going to be the topic of the next video.